Hello, everyone. My name is Sherry Robbins, and my research project was to analyze and detect performance bottlenecks in virtual reality applications. Before I begin, I want to start by explaining the icons on the bottom right. The Ubuntu environment and the Clang Static Analyzer tool was used to help us identify, analyze, and detect the performance bottlenecks. Next up is explaining what exactly a code smell is. This is important because I'll be saying the phrase bad smell quite a bit, and you might not even know what that means. So a bad smell or a code smell is an area in the program that causes major performance issues. I will be presenting on a detection process that was used to detect the bottlenecks. What detection process means is how we obtain the AST, or the abstract syntax tree, for the CPP files we are analyzing. CPP files are just source code files written in the C++ coding language. Let's get into that detection process. Looking over the diagram right there, the user enters the directory in which all the files for the program are located. The directory can contain multiple file types or extensions, and so the team had to find a way to extract just the CPP files. If the directory is wrong, they have to enter it again. If it's correct, we perform a search of directory, obtaining all the CPP extension files. Moving along, if no CPP files are found, we continue to search that directory for those files. If the CPP files are found, we first store them. All the AST files are saved into a temp file, by the way. This allows us to remove the files after we are done with them. Also, we use the clang command to turn the CPP files into AST files. I just want to take a moment here and say that if you're not sure, Clang is a static analyzer. So what this means is it is a tool that allows us to create the AST and analyze the AST files. So as we move along to parsing the AST file now, if no bad smell is detected, we move to the end. However, if a bad smell is found, two processes occur. One, a message with the bad smell is displayed on the screen, and two, the bad smell and its information is saved to the file. Okay, so I went over the detection process in a broad sense. Now I want to focus on that parsing file. The parsing file contains a code that allows us to traverse the AST file, looking for the bad smells or problems. The first part is the libclang interface, and I added this ball because it's important and how we started coding the parsing file. I learned how to code the Clang static analyzer using the libclang interface. First, by inputting commands via the command line prompt to create the AST of a very simple test case CPP file, and then by extracting the method names from that test file. Sounds simple, but it wasn't, but the libclang interface is how we coded the parsing file. Next up is the context information. But before we get into this, I want to mention the bad smell we found. I shared it with you here. It's from GitHub, and I also shared the link to the commit the screenshot comes from. So you see the green highlighted area on the screenshot? This line was added to avoid a bad smell. If we search through the program and didn't see this line, then we know we have a bad smell. In this case, the bad smell was a latency problem. Now, back to context information. The team's first plan was to just search the AST using the parsing file, looking for this variable and if it was set to true. We learned that we would first need to find the context information like function calls, names, and types of variables. Now, moving on to pattern smell. As you can see, there are parsing files specific to find the problem with the variable being set, but this could be reused to find other similar problems. What we would change is the function calls that we looked for and the expressions that were used. Okay, so I just want to wrap up my presentation by going over a couple of things. What went right, what went wrong, and a couple of lessons I learned. Let's begin with the good. What went right? I would say from a research standpoint, being able to find a bad smell was great. And if you look in the dialog box on screen, you'll see a snapshot of the code working. This proves that we're able to find the bad smell. For me, being able to grasp and understand what is happening in the parsing file was a major plus. I've never been asked to use a tool like this before, so I can confidently say it was a learning process for me. Moving on to what went wrong. For me, but not for the team, but installing Clang onto my computer was a major downside, and that Clang took up a lot of storage. So I could say that a lesson I learned was to make sure I had enough memory space in my computer before downloading anything. Asking the right questions also. What I mean is that I've counted a lot of aspects I've never done before. For example, and I'm sorry if you don't understand this, but using the command line code into a program was something I've never been asked to do. So I didn't know how to search online, for example, doing this, but I now know how to thanks to my team. Okay, so thank you for watching my presentation and listening to me talk. I include my contact information if anybody has any questions and they want to ask, but thank you again.